Hey guys, so here's part 3 of the 7.3 notes. We're going to be talking about compounding continuously. Now before we do that, we need to talk about Euler's number. Basically what this is representing, and this is what we're going to be using in our continuous compounding, okay? So basically this is a very special number, kind of like when we talked about I, remember, with imaginary solutions, and with pi, okay? Now we have, so we use a special symbol, I guess a special letter, E, to represent it. So we say natural base E, okay? Now E is irrational, and it's approximately 2.7, blah, 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 blah. Now you can definitely look into more why we get this. The idea, and this is also where compounding continuously occurs, basically we get E when we do 1 plus our R over, or 1 over N. Okay. So the basic idea is that if we continue to plug in numbers into N, our values will get closer and closer and closer to 2.71, blah, 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 okay? So I'm going to go ahead and graph this because we have talked already about asymptotes, because we talked about that with exponentials, so we can kind of do that. Okay, so you have 1, 2, and let's just say 3. So about 2.7, we're going to say here. So as you can say, it's approximately to that, because the idea is that we grow into here. Okay? So one thing is, if we plug 0, let's say in for N, okay, that should just give us 1. So really we should be plugging into here. I should redraw this. So let's say N equals 1, okay? Well, our value we get is going to be, let's say our N is 0. That's the easiest. So our value is going to be 1, because anything to the 0 power is, yes, 0 or 1. There we go. Okay, if we plug 1 into here, that's going to be 2 to the, so that'll be 2, right, at 1. So boom, let's say at 1, boom, and then our values get very, very close to here. So then if we plug in equals 2, right? Then we get like 1 plus 1/2, so that's 1.5 squared. That gives us 2.25, and we can go on forever. So let's say 100. What happens there when we plug 100 into N? Well, we get about 2.7048. So we're getting closer there, right? And so if our N value gets larger and larger and larger, we're going to get closer to that value of 2.718, yada, 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 okay? So the idea is that our N values can go on forever, or like I said, or what I like to say, infinitely many times. It can go on infinitely forever. And so here, that's what's happening. We can get closer and closer and closer to it, and that's going to be part of our asymptote. So this is just a great way to illustrate that when we do compounding continuously, so basically you just compound over and over and over and over within a year, and then of course you do that the next year, there's only a certain amount of money that you're going to get back, okay? Doesn't mean like, oh, I keep getting larger and larger, larger. You get minusculely larger there, okay? So, continuous compound interest, that's going to be A equals P times e to the RT. One other thing I like to say is called it PERT, okay? So here, A is going to represent our final amount. P is going to represent, once again, the principal or the initial amount. Simple. That's a hard word to stop. Oh. E. I'm going to talk to you about what do we do with E. R is the rate as a decimal, as usual. And then T represents time. There we go. Now, the first thing you should be asking yourself, well, how do I know when to use the previous formula? And then how do I know when to use continuous compound formula? Okay, there is going to be a key word. When you are reading a problem, like number 5, so it says you deposited $3,200 in account that pays 6% annual interest, compounding continuously. So anytime you see that phrase, compounded continuously, you have to use PERT. If you don't see that, okay, then you just use the other formula, the A times 1 plus R over N to the N times T power, okay? So those are the 2 keywords you have to look for. If you don't see it in your problem, use the other formula, right? Okay, so now let's go ahead. We're going to use our PERT here because it does say we're compounding continuously. So we have A equals, our initial amount is 3,200. We have E to the, our rate is 6%, but remember we got to change it to decimal, so move that decimal 2 places to the left. And then times the time, which is 2 years. Now let's talk about how do I plug this into my calculator. Okay, so, oh perfect, we have 3,200. Now what I'm going to do is I'm going to press my second key, it's the blue, and then it's going to be what is called the LN button. So you'll see that if you're using the graphing calculator in the first column here. If you're using a scientific calculator, you will also see in the first column. Well, that works perfectly. It's going to be the third button if you're using a scientific calculator. Okay, so you do second the blue button, then LN. Now this automatically gives us E, and then we just plug in 0.06 times 2. And those using a scientific, you should already have parentheses there. So all you have to do is just put in the 0.06 times 2. And then for those using scientific, close out your parentheses. And there we go. Okay. Now later on, we're going to be talking about that natural log button, so hold on to that. But just letting you know, make sure you do second natural log to get E to the X. So if we compound continuously, meaning over and over and over and over again, this is the amount we get after 2 years. Okay. Now, not only does compounding more often will get you a higher amount of money, that does, and it only gets you to a higher amount of money at a certain time, because as I said, now you're increasing at really small increments. What also will increase your amount is actually the rate. Okay, of course, if you have a higher rate, well then of course you're going to get more money back. If you have a smaller rate, you're not going to get as much money. So both the amount you compound and your rate, both of those affect how much money you get. Okay, so our final answer here is going to be 3,607. Don't forget your dollar sign. Or is it 607? No, 67. Sorry. That would not make sense. Yeah, basically your final amount should always be larger than your initial amount. If not, rethink what you did. And then we need to round up, so to 99 cents. Because we have a 9 after the 8, we round up. Right? Now that's another thing. For both, you need to make sure whenever you're increasing or like a growth model, your values need to grow. They need to be larger than the initial amount. Okay? Okay. Make sure you guys work on the homework assignment. If you do have any questions, make sure you contact me. I'll see you guys later.